Okay, good afternoon, class.
Afternoon, sir.
So today we're looking at equations. In particular, we're looking at word problems. Okay. The word problems on page 52. So example 5 is on page 52. So the exercise 5 on page 52. Okay. So to solve a linear equation, that was the last note that we made in our previous lesson. We said that to solve a linear equation, you eliminate the fractions by multiplying every term by the LCM of the denominator, remove all brackets, move all x's to the left hand side, the constants to the right hand side, and then divide by the coefficient of x. Now we're going into, then we said identity. If any real value of x satisfies a linear equation in x, then such an equation is called an identity. Okay. An example of identities are as follows here. You see 2x plus 3 is equal to 2x plus 3. Whatever is on the left hand side is equal to the right hand side. So whichever real value you choose for x, it will work here. Choose a value. 1. Nice. 1 times 2 is 2 plus 1 is plus 3 is 5. 1 times 2 is 2 plus 3 is 5. Choose another value. 6. It's 12, 15, 12, 15. So whichever value you choose, the answer will be the same. Can you see that, people? So then that means to say for this case, x is an element of all the real numbers. Okay. You could already see in number 1 that any real value for x satisfies the equation. Okay. Let me just see here what is going on here. Again, let's solve the sum here. So we spoke yesterday about the case where you have no real solution, and this is where all the solutions work. So in yesterday's case, no solution would work. In this case, all the real values will work. Okay, you see the difference. So here we got 2x plus 4 plus x minus 9 is equal to 3x minus 3 minus 2. So we solve for x is going to give you, of course, 3x minus 5 is equal to 3x minus 4. Can you see? This is called what again? An identity. Okay, which means to say whatever is on the left hand side is equal to the right hand side. Later on, when you see 0 is equal to 0, or 12 is equal to 12, that is all identities. Okay? Left hand side is exactly the same as the right hand side. So this is what we call an identity. And to answer this, we say x is an element of all the real values. So all the real values will satisfy this equation. Okay, that is just a side note before we go into problem number patterns. No? Word problems. Okay, so solution of problems, the whole object of solution of equations is able to solve practical problems. Practical is like real life problems. Okay? And we have many of those. Not so? Yes. The so-called story sum is reduced to an equation which can then be solved. Okay, so they give you a little story to read. Okay, and this is the reason why we do English. Okay, is to read your maths paper. This section will cover easy examples. Okay, as you guys get a bit older, we must spice your life up a bit. Okay, so work carefully through each one. People, this stuff is fun. Okay, we're not always going to get it right on the first time, even myself. Okay, so the guidelines: read the problem. I think that is the problem, reading. But okay, read the sum. No? Decide what x will be. Example: the number, the width, the boy's age, the distance, etc. Then begin with let the width or the number or the boy's age, whatever be, x. Okay. That NB is not for me. Okay. It is important to note. Further guideline for the steps. If there are two unknowns, then the smaller one be x. Okay. There's nothing wrong if you let the bigger one be x, but if the bigger one is x, you're going to then rather subtract and divide. Then if you let the smaller one be x, we're then going to rather add and multiply. Does it make sense? So if you go and you make the bigger one x, you're not going to get it wrong. It just makes stuff a bit more complex. Okay. But they make it a habit here, making the smaller one x so that everybody is uniform. Okay. Or check what requires quantities. For instance, what is the actual question? If the question is to calculate the distance, we make the distance x. If the question is to calculate Paul's age, we make Paul x. You guys understand? Alright. So find the distance and let that be x. Alright. Then we are told if two items are involved, express one in terms of the other using x. For example, the son's age is x, so the father will be 3 times as old as the son, which is 3x. You guys understand? Instead of if you had made the father x, the son would have then been x over 3. You understand? Then it's going into fractions, which we want to avoid. Not so. According to when we marked this work as well, the previous exercise, I could see the fractions got you down. Okay. So if the width is x, the length will be x plus 10. It also depends on the story. Okay. Number 4, now set up an equation, solve the equation. Again, read the actual question. Often the x that you have chosen and solved does not represent the answer to the question. So it's important to read the question and to make sure you actually answer the question. Okay. Number 7, ensure that you give a logical answer. So if you get the son's age to be minus 3 years old, imagine they didn't think of him yet. No? So he can't be negative. No, the son's age can't be negative. Okay. And the breadth can't be minus 5 centimeters. You measure a rectangle and you get minus no. So the answer must make sense. Alright, you guys understand? Right. Now remember, 7 times a number is 7x, and 7 more than a number is x plus 7. So that's the introduction to this word sounds or story sounds. Okay.